Hello everyone, welcome back. This is the second video regarding MQTT weather station. It's about web interface of a weather station. In the previous video, we connected a sensor DHT11 to the microcontroller ESP8266. We wrote and uploaded code to the ESP8266. And thanks to that code, ESP8266 collected data from DHT11 sensor. And that data is the humidity and the temperature of the environment surrounding the sensor. Also, thanks to the code, the ESP8266 published data to the MQTT Broker running on the VPS with this IP address. To view the published data, we had to subscribe to the topics published from the ESP8266, and that required the installation of Mosquito with double T on our PC. We use the terminal with the command mosquito sub and this is the option H for the host, and the host has this IP address, and the option T for the topic, and the option V if we want the variables. If you don't want variables, we'll simply display values. But if we add the option variables, we see both the topic and the value. Okay, this is how we viewed data in the last video, the last session. Today, we're viewing data using the web interface. And as you can see, data is changing live without refreshing the page. This is the code for the page. The page is running on my computer. Here is the code. And as you can see in the code, we have this JavaScript code. And in the header, we included this library, MQTT min. You have the same code here on our GitHub account in the repository of MQTT based projects under the folder IoT Data Viewer. This is the same code. Viewing data using a terminal is good, but that's for experts. that are testing the system most of the times. For a common user, we need a graphical user interface like this. Let's dive deep into how that works. This is the system structure and data flow diagram. We have the sensor here, the HT11 sensor, that measures temperature and humidity. Data flows from the sensor to the microcontroller ESP8266. ESP8266 is considered as the client number one. It sends data to the VPS with this IP address. And there is a service that we call the service number one, MQTT Broker service, which is running on the port 1883. Data is transferred from the MQTT Broker to the WebSocket, which is the service number two, running on the same VPS, but at the port 9001. Whenever there are updates from the MQTT Broker, the WebSocket server will be pushing those updates to this client or your PC. Let's compare HTTP polling versus WebSocket. HTTP polling is a technique where the client repeatedly requests data from the server at fixed intervals, regardless of whether new data is available. This is inefficient because many requests may return the same data. This is the code to poll data every 5 seconds. Remember, you have this documentation at our GitHub account. In this code, every 5 seconds, the browser asks the server for new data. The server will respond with the latest available data. And if no new data is available, the request is still sent. The use case is simple applications where real-time updates are not critical, like checking for new emails in a webmail service. What about WebSockets? WebSockets provide a persistent connection between the client and the server. Like polling, the server only sends data when there is an update, making it more efficient. This is the example code where the browser opens the WebSocket connection and the server pushes data when there's only a real update. And that reduces unnecessary traffic. The connection will remain open and the responses will be instant. The use case is applications that require real-time updates like stock market tracking, live chat applications, IoT sensor monitoring, or multi-layer gaming. These are the key differences. Polling sends frequent requests, even when there is no update. WebSockets keep a single connection open and only push updates when necessary. Polling wastes bandwidth if the server has no new data, while WebSockets are efficient and deliver instant updates. When to use what? Use HTTP polling when updates are infrequent and real-time data is not critical. Use WebSockets when low latency and instant updates are required. For example, if you're building a weather station over MQTT, WebSockets are the best choice since temperature and humidity updates can happen unpredictably. Today, we've covered how MQTT works with WebSocket to help the publication of data collected on the other end of the earth. I hope you enjoyed this session. Until the next time, bye.